Hello everyone, my name is Sung-Hoon Lim from Hanyang University. The title of our paper that I would like to introduce is Analysis of Multi-Source Language Training in Cross-Lingual Transfer. In this presentation, I will discuss how incorporating multiple source languages affects multilingual LM and cross-lingual transfer. Cross-lingual transfer refers to a set of mechanisms that leverage information from resource-rich source languages to enhance task performance in relatively resource-poor target languages. Many methods have been proposed to improve cross-lingual transfer performance, and one of the methods is training model on multiple source languages. Now we call this method as MSLT, which stands for Multi-Source Language Training. While MSLT has been shown to significantly enhance cross-lingual transfer performance, research on the underlying region and its efficient utilization is insufficient. In this work, we introduce a series of comprehensive analyses exploring the inner workings of MSLT, along with offering guidance for its effective utilization. First, we assume the use of multiple source languages from the perspective of prior researches, language-specific and language-agnostic information. By utilizing more languages, we expect the model can better distinguish the language-agnostic information, resulting in performance improvement on languages that are not used in the training phase. For example, in the case where only English is used for training, model learns representations solely on English, resulting in incorrect boundaries for instances of Korean that are not included in the training data. However, when two languages are used for training, model can run additional information about language agnostic features compared to using only English. As a result, model can better classify instances of Korean that it previously couldn't. To validate our assumption, we conducted a representation visualization of parallel sentences in English, Arabic, and Indonesian. The figures above illustrated the representations formed by a vanilla model trained with English, and a model trained with three languages, which is English, Spanish, and German. In the case of the vanilla models, the representations for each language are distinctly separated. Here, here, and here. But when trained for a classification task, representations for each language started to align as shown in the middle and right figures. Comparing the middle and right figures, it is evident that using multiple source languages leads to better alignment of representations for languages not used in training, such as Arabic and Indonesian. From these figures, we confirm that increasing the number of source languages enhances the ability of aligning multilingual representation. However, increasing too many source languages can potentially have side effects on performance. Based on three classification tasks, we investigated the optimal number of source languages. The result indicated that using three languages yield the best performance, and over three languages resulted in either negligible improvements or even a decline in performance. In the previous section, we demonstrated the positive impact of MSLT on multilingual representation and identified that using three languages is optimal based on our experience. Now, we focus on the impact of source language combinations for MSLT setting. First, we conducted experiments to assess how performance varies with different language combinations across 5 classification tasks. Results showed that the performance difference could range from approximately 3 points to more than 10 points, depending on how the language combinations were configured. However, Considering all possible combinations is impractical, so we need criteria to form the best language combinations without evaluating every possibility. To address this, we define several criteria to measure the relevance between languages and conducted experiments where these criteria could maximize MSLT performance. We use three approaches for our experiments. First is the size of pre-training data, which picks top three languages that are most included languages in the pre-training data. Second is the vocabulary coverage, which compose language combination that covers the largest part of the total vocabulary. Last is linguistic diversity, which follows the intuition that the lower similarity between languages, the more diverse the combination becomes. We measure embedding similarity and language feature similarity using length to back and compose the combination whose similarity average is the lowest. This table is the result of experiments for 5 classification tasks. Results show that composing combination with data expect did not make good language combination. But in the case of maximizing linguistic diversity, language features using length to back is better performance, which can be utilized for source language selection criteria. We also conduct an experiment that diversifying combination really work and confirm that increasing diversity by composing languages whose similarity averages are the lowest show better performance than the highest similarity averages. That's all for the presentation. To wrap things up, let me give you a quick summary of what we covered. First, MSLT positively impacts cross-lingual transfer by improving performance and aligning multilingual representations better than single-source approach. Second, simply adding more source languages isn't always beneficial. Adding more than 3 languages can hurt performance. Third, how you compose your source language combinations is very important. Finally, diversifying language features can help in forming the best source language combinations. This is the end of the presentation. Thank you for listening.